Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the deadlock in operating systems. Deadlock. A process requires the resources. If the resources are not available at the time, the process enters the wait state. The waiting process may never change the state again because the resources they have requested are held by the other waiting processes. This situation is called the deadlock. The process must request the resource before using it, and it must release the resource after using it. Here we have the three stages. That is, first one is request. If the request cannot be granted immediately, then the requesting process must wait until it can acquire the resources. Second state is use state. The process can operate the resources. Third one is release. The process releases the resources. Next one, deadlock characterization. Four necessary conditions for the deadlock characterization. First one is mutual exclusions. At least one resources must be held in a non-shareable mode. That is, only one process at a time can use the resources if the another process requests the resources. The requesting process must be delayed until the resources has been released. Second one is hold and wait. The process must be holding at least one resources and waiting to acquire the additional resources that are currently being held by the other processes. Third one is no presumption. Resources cannot be presumpted. Fourth one is circular wait. P0, that is process 0, is waiting for the resources that is held by the process 1, and the process 1 is waiting for the resources that is held by the process 2, and it goes on. Next one, methods for handling the deadlock. First one is deadlock prevention, second one deadlock avoidance, third one deadlock detection, and then deadlock recovery. First one, deadlock prevention. Deadlock prevention is the set of methods for ensuring that at least one of the necessary conditions cannot hold. Second one, by ensuring that at least one of these conditions cannot hold, we can prevent the occurrence of the deadlock deductions. For this, we have to denying the mutual exclusion and denying the hold and wait option and denying the no presumption and denying the circular wait. Second one is deadlock avoidance. Deadlock avoidance requests that the operating system be given in an advance additional information concerning which resources the process will request and use during its lifetime. With this information, it can be decided for each the request whether or not the process should wait. To decide whether the current request can be satisfied or must be delayed, the system must consider the resources currently available, the resources currently allocated to each process, and the future request and the releases of the each process. Next, here we have that two algorithms are used for the deadlock avoidance, that namely resource allocation graph algorithm and the Banker's algorithm. Uh, the resource allocation graph algorithm, that is single instant of the resource type, and then in the Banker's algorithm we use as a several instance of the resources type. Next one, deadlock deduction, that is single instant of the each resource type. If all the resources have only a single instance, then we can define the deadlock deduction algorithm that use a variant of resource allocation graph called the wait for graph. Here it is a diagram for the wait for graph. Here we have the resources defined as R1, R2, R3, R4 and R5, and we have the process defined as P1, P2, P3 and P4, P5. If the process P1 requests the resources 1 and the request resources 2 also is given for the process 1, like this graph is known for wait for graph. Next one, deadlock recovery. First one, process terminations. About all the deadlock process and about one deadlock process at a time until the deadlock cycle is eliminated. And then after the each process aborted, the deadlock deduction algorithm must be invoked to determine where any process is still deadlocked. Second one is resource presumptions. The presumption some resources from process and give these resources to other process until the deadlock cycle is broken. Here we have the three divisions. First one, selecting a victim, which the resources and which process are to be preempted. Second one is rollback. If we preempt a resource from a process, it cannot continue with the normal execution. It is missing some needed resources. We must roll back the process to some safe state and restart it from the another state. Third one is starvations. How can we guarantee that the resources will not always be preemptive from the same process? Thank you.